Hello friends, this is the Unit 2 DC motor and today we will discuss about the types of DC motor. Okay, lecture number. Now come to you will understand about the types of DC motor. The types of DC motor similar to the types of generator also same. But the point is the types of DC motor again divided into two parts. One is your self-excited, another one is your separately excited. Then you can see here, if I will write, then DC motor broadly divided into two parts. That each one is your separately excited, another one is self, right? Then self-excited is further divided into three parts. That is, you can say, that is your DC shunt motor, then DC series motor, then DC compound. And this compound motor is again divided into two parts. You will see one is your long shunt motor, another one is your short shunt. Okay, and these motors will discuss the constructions, everything we'll discuss, and the equivalent circuit of these connections like separately excited and self-excited, and each individual motor components we will discuss here. Then first come to the okay. First we'll understand about the separately is the design of the separately excited motor. There is a field winding, there is a armature winding, and if you see, I'll draw the circuit diagram of this one. Then the field, there is a variable resistance we connected to vary the field, and there is a field resistance, and it is connected to the supply. We can say that it is a field voltage. This is a variable resistance RF, and you can say this is your field resistance at capital F output. And what will happen? The armature winding is presented here. Armature winding, there is an armature resistance. There is an armature, okay, and it is connected to the right. Now, if I will draw the current directions, you see, as the source voltage is here, then definitely the field current will pass from this circuit left hand side, and due to the mutual inductance, what will happen, and the current will an EMF is induced across the armature, that is the back EMF, and due to the back EMF, what will happen? These are the cross drops V1 and V2 you can consider, and another one is your this is your armature resistance, and we can say from EB to RA there is an armature current will flow, and across the load current will flow, that is your VL. Okay, these are the complete circuit diagram of the DC separately excited motors. Nothing more, much more that in this equation, but one thing you can calculate, that is your field current you can calculate, and as the equation you can see here, first we calculate the field circuit. Then field circuit you see what is there. Then that is your how to calculate the equation you see, that is if I will see in the left hand side equation, you see this is the plus or minus. Then if I will write the KVL for that one, then VF minus your IF R small f, okay, then minus IF R capital F, okay. Then 2 points you can confusing, if you add you can make the rename of this RF, okay. Then equal to G. This is one loop which complete. Now my point is how to calculate the IF. IF equal to, you can see that is EF by the RF small f plus R capital F. This is the formula of DC separately excited field current formula, equation 1. But the point is the small RF, the small f is the variable resistance, and this is your constant resistance. Okay. And if I will vary this variable resistance, because constant resistance always it is constant. If I will vary this one, then what will happen? It will affect this IF. That's why the field will affect the flux. Okay. And in this manner, if I will go to the second side, this is the second, then in secondary side also we can write the voltage equation. If we flow the current direction like this, what is the voltage equation will come? That is our EB minus IA into RE minus VL, and another there is two brush. Okay, V1 and V2. Then we can, due to the brush, we know that carbon brushes are there, and for that also some voltage drop will occur, that is known as minus BB, right? Then if you will see this equation, then some cases what will happen, the VB is always 2 volt. Okay, given then the question. If also you neglect this one, then what is the VL? We can say EB minus IARA. If you are neglecting the BB, if in the question it is given, then you can also write down. Then this is your equation number 2. Load voltage equal to, what is the load voltage? That is nothing but your back EMF and voltage drop, right? Now come to the point. These are the two important equations, and from this equation you also find out the armature current. Armature current is nothing but that is your total voltage minus EB by, also this is the third equation. You can then overall if you will see this DC separately excited motor, so we already calculated the IF. If we any other color you can mark. This is one point we already calculated field current, that is your voltage, load voltage, and this is your armature current. You see, except this, these three are very important to calculate. And what are the important factors? And you see in this section here there is a variable, that is your load voltage is the variable, and here another variable, it is the RF, that is the variable resistance. Okay, when I will discuss about the characteristics of this DC motors, then I will show you how these variables are important, because due to this variable the current values will change. Okay, these are the DC separately excited motor, and we this type of condition already we discussed in the generator section, right? Now come to the second motor type, that is your series or self-excited motor. Okay, in self-excited motor, I already told, in self-excited motor there is two types, sorry, three types. That is, one is our DC shunt motor, then another one is your DC series, then third one is your DC compound. Okay, and first will DC shunt means it is a parallel connections of the armature resistance and field resistance are connected in parallel. And DC series means here armature and field resistance are connected in series. And DC compound means we'll see the construction of this one. This is like slightly different, or this is nothing but this is the combination of DC shunt plus DC series. How we can do and what is the need of this DC compound motor? Today we will only see the explanation of the DC compound motor, but when we will do the characteristics, then we will understand why we are doing this. Okay, now First, we'll come to the drawing of DC shunt motor, then a DC shunt motor. Draw the circuit diagram first. Then if I will draw the circuit diagram, then I told that field and armature is connected in parallel. Then what we will do, draw a line. There is an armature resistance. Okay, that is your armature. And here there is one field. And this is just okay. Now, suppose here I have written that is your VL. Then what we will do? If this is your VL plus and minus, now see, this is your armature resistance, this is your back EMF, this is your V1 and V2 again, and here this is your field RSH. And we can write that RSH equal to your field resistance and RA equal to your armature resistance and VL equal to your load voltage. Then EV is your back EMF, V1, V2 are process. Okay. If I will talk about these things, then what are the current flow? First, find out the current flow. Current flow, to find out the current flow, I'm just using any other color. You see the VL, then definitely it is your IL. Okay, and suppose I am marking this point as a point. First, all points I am marking because parallel A B. You can say these are C and D. Just put E and F, right? Now, point we have to discuss that the current is entering to this IL, but you see there is a node coming in this point. And in this point, when the current is entering at this point, what will happen? This is still IL, okay? But at this point, the current is divided into two parts. One is here downward, that is your IA. Another one is here towards C, that is your ISH. Here, so that means in field circuit, the ISH current will flow, and in armature circuit, the armature current will flow. Then two other thing you can write, that is your shunt current, or we can say field. Third one is the another one is the armature current. Okay. Now we'll derive all the currents and the relations. You see, if this is you see the current is divided at the point A. A means the current ISH and IL. Each current is divided, and we can say the current equation, initial current equation. That is the shunt motor, the initial current equation. Can I say at point A, if you see, then the incoming current, that is IL, equal to the summation of the outgoing current, shunt current plus armature current. First point, right? And this point, if we will understand the IL equal to ISH plus IA, then I can say the field and armature is connected in parallel here. The field as well as armature connected parallel. Okay. Now next point is, you see, If it is connected in parallel, then what will happen? All the voltages in this circuit is equal. Then you can write easily that a VAB equal to VGD equal to VEF. These are the voltages. Then VEF voltage already given. Then you can say VL, or we can write down the equation for this closed loop also like this. What is the equation will come in this circuit? That is your VL minus IARA minus EB equal to G, right? This is the equation, definitely. Then if you will solve this equation, then what will happen? Either you can write the equation that is your EB equal to VL minus IARA, and EB is nothing but that is your mechanical voltage component. Okay, that's why this is nothing but the electrical voltage supply minus the drop. Then only the mechanical voltage we are getting. If we are considering this EB is mechanical voltage, why I am telling the electrical voltage we are giving. Then due to the electrical voltage, whatever in motor case, your armature will operate, and this armature also, this armature will rotate. There is some back EMF is produced. That is nothing but this. Okay, getting clear? Now you can, from this also you can find out the IA value. How to find out the IA? IA is nothing but we can write here IA equal to EB minus EL by R. Sorry, you can change this one. That is VL VL minus EB by R. If you solve this one, you will get this. Okay, just take this point to this side, and VL minus EB and by R. Now come to the shunt current. And I told as these are all are connected, the armature and field are connected in parallel. Then again another term will come, that is your VAB equal to VCD. If this will happen, can I say VAB equal to VCD or VEF? Then we know already VEF. VEF equal to V. Then can I write here in this that VEF is equal to VEF is equal to your VCD. Now VEF we know that VL, and what is VCL? VCD is the multiplication of the current, shunt current as well as the shunt resistance. Then we can easily find out the ISH, that is your VL by RSH. This is also one. You see, we are calculating, one is your shunt current, one is your armature current, another one is your mechanical voltage components. Okay, electrical voltage also you can write VL equal to EB plus IARA. These are the DC shunt motor explanation. If any doubt, we can share in the comment. Now we'll discuss the next one. That is your DC series motor. Come to the point here. DC series. When I'm talking about the DC series motor, then first we come to develop the DC series motor. Then in this already we know that field and armature is connected in series. Then first you do the armature resistance. This is your back EMF, and this is your field resistance. Then it is applied to voltage. Okay. Now that is your load voltage. Then you can say this is load current. This is your series current. This is your armature current, and we need to enter to this that is your back. Okay, and this is most the simplest one, no problem at all, because it is only one loop. You will find out means it is easier to solve. You see, if I will put KVL to here, then you can easily solve. That is nothing but if you will write here also VL minus ISE into RAC in this equation, that is your minus IA into RA minus EB equal to 0. But this is the equation I have written. One point you have to remember, otherwise I am writing here armature and field is connected in series. Okay, keep in mind. And if it is connected in series, then can I say all the currents what I mentioned IL, IAC, IA all are equal. Then you put a remark that IL equal to IA equal to IAC in series. But sound it is different. Shunt is your IL equal to IA plus ISH. Okay, don't be confused. In series, all the currents are equal. If all the currents are equal here, then can I write the simplest equation to find out the armature? Suppose I have to find out the armature current. Then how to find out the armature current? Then again, what I have the written in the equation 1, then again you write here, due to the equal currents, in place of this IAC, I am writing out the IA. VL minus IA into RAC minus IA into RA minus EB equal to 0. Right? Then we can, when we are finding out your IA, then what is the equation will come? IA nothing but VL minus EB by RA plus RAC. Similarly, you can also find out for IAC with the equation, otherwise you can put this one. Give this formula and you can write down. Okay, these are the very simple equations what we developed for the shunt and series. Now come to the understand the compound motor. The compound motor, very important thing. First, we will draw the understand the compound motor. Compound motor is the combination of shunt and series. Okay, shunt motor already you understand. In compound motor, when we are understanding, there is two types of compound motor. One is your long shunt, another one is short shunt. Short shunt means what will happen? The when we are connecting the armature resistance or armature windings, uh, you see here armature winding plus the series resistance we are adding. Then if we will completely connect the circuit or it will cover the field winding, then it is a long shunt. If it is the not covering the series, only covering the armature, it is in um, short windings. Okay, short compound motors. Then first come to the compound motor circuit diagrams. And initially we discussed about the long shunt. Then everyone first long and compound motor. Okay. In a long shunt compound motor, first draw the circuit diagram of the long shunt compound motor. Then in the circuit diagram, modifications first use. There is this additional series resistance and it is connected to the armature resistance in series. And there is a armature. Okay, this is only the developments. And other is looking like a shunt. Same. there is a field winding, and this is your supply. Okay. Now you see in this point what will happen. The current is entering, that is your IL current. This is your VL. Okay, supply. Then when it will enter, then initially it will be the series current, then it will be the armature current, and it will go to the produce the back. But here what will happen? It will divide it into another current, that is your shunt current. Okay, and if I am putting the resistance values first, that is your armature resistance, this is your series resistance, and this is your uh, shunt resistance. Okay. When I am coming to this field, then you see here in this circuit, long shunt compound motor initially will explain. How will explain? First come to the point, that is your this circuit you take, otherwise you can take the nodes, whatever may be the wish. First you put some nodes here for your simplicity, that is your A and B, C and D, and E and F. Then can I put here, if the circuit is connected in parallel, then when the current is divided into two parts, the first current equation everybody write down. That is your load current equal to your series current plus shunt current, right? Then if I am talking about the series current, then can I say here in this, by seeing the equation, by seeing the circuit, then series current is nothing but is equal to your I current. Keep in mind this two equation, equation 1 and equation 2. This is all about your current equations. Why this is ISC equal to IA? Because the series resistance connected in series. Okay. Now when I am talking about this circuit, now you just consider this loop. Here I'm changing. Then if I am changing this one, you just write down the equation. That is your, you can say that E, C, D, F. Okay, the closed loop. Then what will the equation will come? That is your load voltage minus IAC into RAC minus IA into RA minus EB equal to 0. Suppose I have to find out the IA. How to find out the IA? Then you can say that it is nothing but in place of IAC, you just write down the IA, because IAC equal to IA. Then what will happen? That VL minus EB by RA plus RAC, that is equal to I. Okay, that is your equation number 3. Now, on the point we have to understand that if now we are calculating this IA, but if you will compare the Shunt and series, the equation will differ. Now come to the point next, how to calculate for the field current. Then for the field current, that is very simple, that you see the voltage across AB equal to voltage across EF. If I am talking about this one, voltage across AB means that is your ISH into RSH. And voltage across EF means that is nothing but your VS. If I will calculate the ISH current, then what is the relation? That is your VL by IS. VL by RSH. Okay, question number 4. This is all about your long shunt compound motor. Okay, and all the parameters we detail explain about this long shunt and connections. Something is different, that is, you see, in shunt motor already you see there is a armature, there is a field, there is a armature, but in addition to that, only the series resistance is connected across this series with armature. And what will happen, this is due to the connection, you can compensating the armature reactions. Okay, that's why the compound motors develop. Okay, and also if you will understand in the next preceding classes, that the to improve the voltage characteristics, also we are using these combinations, because when we will discuss about the characteristics, then what will happen, in shunt motor the voltage will be gradually decreases, but in series motor the voltage is gradually increases with increase in load. Okay, but in if you are increasing in load in shunt motor, then voltage will be gradually decreases. But in if you are increasing in load in series motor, what will happen, the voltage will be increased. And what will happen, we this is practically impossible. If your voltage will be increased, maybe it will damage your circuit. For that reason, we have to choose one better solution by which our voltage should not be decreased more and should not be increased also more. That's why the combination of these two we are selecting, that is as a long shunt compound motor. Okay, now come to the shunt. Similarly, the design also will understand, and the electric. That is the second type of compound motor. You can write down, that is your short shunt compound motor. Little bit only the circuit diagram changing is there. Then you can see in short shunt also same, there is an series resistance, and if we there is an armature resistance, there is an armature. Okay. And here in long shunt we are connecting from this series, but no, in here what we will do, we are connecting this circuit in between this. This is the filter, and this series joining you can keep the supply. This is your voltage. Then what will happen, this is your load current. When the current will be enter here, this is your series current. When because first just this is your series resistance, armature resistance, shunt resistance. Okay, and this is your vacuum. Now you see the current direction. This is nothing but your series current, and at this point, what will happen? The current is divided. That is your shunt current, and this is your armature current. This is all about the circuit diagram. First, initially we will write the equations, that here the series current equal to the armature current plus the shunt current. One equation. From this point, if you will observe from this point, the IAC, that is incoming current, equal to IA plus ISH. This is the outgoing current. Now you see another thing, that here the load current as well as the series current both are equal. Then here I can write IAC equal to IA. Okay, equation number one. Now we will solve the equations. How to solve the equations and calculate the current and voltage. Now suppose you are considering this loop, right? In this loop, if I will write the equation, then can you write this one? Right first. That is your load voltage minus IAC into RAC minus IA into RA minus EB to 0, right? Now one term you just see here, if I will write here, let this equation is like that. Okay. Now you see, if we know that this is the Here the current is divided. ISC is coming, and what will happen? The current will be divided into two parts, right? That means this field and this armature is connected in parallel. Then can I write, if suppose this is the node, I will put A, and this is the node, I will put B, and here the node I will put C, and here the node I will put D. Then can I write that VAB equal to VCD due to the parallel? We can also write here due to the parallel connection. Okay, if due to the parallel connection, this is happening. Now you see VAB. VAB, what is the voltage? That is, can I write here? VAB is nothing but IARA minus EB equal to your ISH into RSH, right? So it is your IARA plus EB, right? And here you just see there is a term in equation number 2 minus IA RA minus EB is there. Then if I will write this input this, suppose this is equation number 3, you see, if I will put here, then what is the equation will come? Now you can write here, putting equation 3 in equation 2, what is the outcome will come? Can I write here? BL minus ISC into RAC equal to your ISH into RSH, right? And here also, if you can write, you want to calculate your ISH, then you can easily calculate that is your VL minus ISC into RAC by RH. This is very important formula that you have to solve. Okay. And from this equation also, if you are getting the ISH, then you can also calculate your IARA. That is the aspect you can also solve. Okay. But point you want to understand that in short shunt compound generator, that is your armature and field is connected. The series resistance is not connected to this, fully not connected. Then what will happen? Initially we found all the currents, and based upon the currents we are counting the solving the loops. Then we can calculate the field current as well as the armature current. Today we will discuss about all the types of the motor. That is your, initially again I am telling, self excited motors, okay, and separately excited motors. And if okay, now conclude your lectures. Concluding the lectures, you just see whatever we understand today, that we will summarize. That DC motor are categorized based on how field winding is connected to the armature circuit. First, remember that without connecting this field winding across the, means if you will understand how the field winding is connected to the armature in parallel or series, or this field and armature is connected, and the series, another series resistance is added in case of compound, that depends upon the field winding connections. Okay. Then component 2, that is the different type of DC motor offer various characteristics like speed regulation, torque regulation, and load handling capability. These things we will discuss in the characteristics. Third party, the selection of the DC motor type depends on the application requirements such as starting torque, load variation, and desired speed. And each motor type has specific advantages and limitations in terms of efficiency, control complexity, and mechanical performance. Okay, these are the summaries of this lecture. Any doubt, you can put a comment, okay, in the comment section. Then in the next lecture, we'll discuss about the characteristic this of DC motor In this, the speed versus current, then torque versus current, then what will happen? Torque versus speed. Okay, we'll everything we will discuss in this. Okay, electrical characteristics we will first calculate, I mean, understand, then we will go for the mechanical characteristics. Each component we will discuss in the next class about the characteristics. Thank you very much. And any questions you can ask.